now we already come to the best part of this presentation, which is a demo. So let's open up our terminal to open that. Let's move out our presentation for now. And this is my terminal. So I'm using terminal for everything, including my iCodes in my terminal. And of course, I'm using Vim. So let's go to the folder location. I will use J and then space of the name of the project. And then boom, I can come there. And I will open up my NeoVim. Before that, I will open my Tmax. Okay. And then I will open Vim. But I know that it might a little bit so small, so I want to make it a little bit bigger. Okay, now I will open my Vim. So as you can see, I will open the project structure here. So of course, like this is a README, and then you can see from the video description the repository in GitHub. And let's open up the modules. So now our Scala source is actually all contained inside this folder, and this all is actually a sub project. So if I don't have these modules, like maybe in the future I will have another folder for infrastructure, like I will have some folder about Docker, another folder about Terraform. So and then I also have this kind of folder. So now my folder will be messed up because I'm starting to lose which one is for infrastructure, which one is my ZIO. So for this purpose, I create these modules. Now our ZIO will locate it all inside the modules, and then maybe for the other infrastructure kind of purpose, I will create another folder for that. Okay, so now if you open my build.sbt, we have many sub project here. So basically, all of this folder here is actually a sub project. So if you still remember from our discussion before, so we have our core, like the bottommost layer, okay? And then this is actually app and infra layer. It is actually located in the layer 2. So core is layer 1, and then app and infra, both layer 2. They are in the same level. But also, we also discussed that app has boot, okay? So we will discuss later, but we can see that app has a small folder boot there, okay? And also app has small folder boot there. So that's how I implement boot layer. So it's actually not a single project because it's actually part of app itself. Okay, so let's see. I mentioned before that app only accessing core, only depends on the core, and then infra is also only depends on the core, and core doesn't have any dependencies. Okay, so let's prove it. So let's see in the core. So core is basically this, and then core is actually only depend on these libraries. So if you open it, so it's basically only cat, ZIO, and stream, which is okay. So I will consider our ZIO and streams, as you can see it here. So this is the dependencies of our core, those libraries, cat, ZIO, and streams. Okay, so basically, I will consider that as part of the core Scala, right? So it's okay if we depend on ZIO because this is a ZIO apps. So that's core. And then here comes our infra. So this is infra for HTTP client. So basically this is describing this infra client HTTP. Okay. So we can see this. This depends on core only core, nothing else. Okay. So this is infra HTTP client. And then also infra repo memory. It's also only depends on core. And this is for our apps now. So this is our app for HTTP and our apps about CLI. So CLI is like command line kind of application. So command line, it depends on the core, but actually I make a small here. What is this? We also depends on infrastructure. This means we are depending on another project, which is here. Look at that. So we are actually depends on this. So app HTTP depend on this. But yeah, so basically this depends on here. I meant it to be from our boot because our boot and our apps is not separated. They are come together in one project. So that's how it's ended up being there. Yeah. So let's come to our core now. So now our core. So it's like my main core is like divided by algebra. So our core has invoice algebra, subscription algebra, and scheduler algebra. Okay. Basically, some of other projects you might see like one project, if you open the folder, okay, so it will contains maybe service folder, and then inside the service folder you will see all kind of services come up together, and then also inside that inside the another folder other than service, you also might see repository, and then if you open repository you will see all kind of repository in that folder. So actually, rather than putting like organizing your Scala file based on those functional folder, I would like to subdivide our core by algebra. It means I don't have any particular folder repository because like or let's say a invoice, sorry, HTTP client or client kind of folder, and then you open that folder, you will end up like opening all of the clients. So I don't like that like structure, so I prefer like organizing by algebra. So we have algebra here. So in algebra we have the algebra of invoice. Okay, so we can create invoice and we can get invoice. So basically algebra is only like, as we have discussed before, it has operation and also it has operand. So operand is the model. So this is the model. So it's located here. All is located in one folder. So the algebra and then also the operands or the models. So this is the algebra for it. Okay. So you can see that some algebra like invoice and also subscription. So we can see the algebra, which is the trait, but we don't see the implementation of the traits. Okay, so where the implementation might be located. Okay, so before I mention that, let's come to another algebra which is called subscheduler. But before continuing, I will remind you what this application is all about. Okay, so this application is all about like billing scheduler. So you can have an invoice, you can have a new invoice, and then based on the invoice, I want to schedule that particular invoice must be processed maybe like in the future. Okay, so that's basically like in scheduler. So I can add a schedule entry. So let's say I have a new invoice and then I want this to be invoiced maybe next month. Okay, so because this is like a recurring subscription, so whether I have a new subscription, it means I have a new invoice. Okay, so new invoice, and then I want this invoice to be billed next month. It means I want to put a schedule entry in this subscheduler algebra. So in this algebra, we can add a new schedule entry. So schedule, basically we have like the referring invoice, like with which invoice you want to like charge or do you want to process. Okay, and then this is like the due. Okay, so let's say I want to put schedule maybe next week, right? So the due will be put next week. Okay, and then the invoice ID will be referring to some particular invoice, and then I will put there, and then a week later it will be picked up by our applications, which is called scheduler, and then it will be handled properly, maybe by charging or doing like renewal of subscription. So that's basically our domain. So this is the algebra of scheduler. So we can have like this is about entry, about billing entry. Okay, this is not about the invoice because the invoice is in this algebra, but we are talking about scheduling. So this is like a scheduling algebra, but the name is subscheduler, which means subscription scheduler. So we have get, save, and remove. Okay, so we want to get a particular schedule. So this get will return a schedule. So every algebra here is returning an ZIO IO. So it might get an error, which is a sched error or a schedule. So so inside algebra, so you have algebra. Okay, like for example invoice, you have algebra, you have the model, and you also have error. Okay, so you will define any kind of error. So back again to our algebra here. So we can put a new billing entry to be scheduled to be picked up maybe next week, or maybe we want to remove that that entry. Okay, so this is actually like maybe in the apps layer it will implement it as a RESTful service. And then this is the interesting part. So I want to see all of the billing schedule that is due, so it needs to be processed. So this algebra can do this operation and it will return a stream. This is ZIO stream. Okay, and it will returning a stream of schedule. So stream is like a list, but if you know ZIO stream, what is the difference between a stream and a list. So think about, if we have like 1 million of list of E, let's say a list of entry. So list is actually all of those 1 million will are already resided in memory. But if we are talking about stream, so let's say I have 1 million entry of due schedule. So if I get the stream, so I will might only get the first 100, and then I process it, and then I will get another 100, and I will process it. So list, everything already in the memory, and stream is not. So you only get it one by one. So that's why stream is very powerful here. Okay. Now we can also have the operation of processing all of the outstanding invoices. Okay. So this processing, maybe internally it will also call this. Okay. So this operator, this operation maybe will use this stream due schedule. Okay. And of course, that's our algebra, and then we have the model, the operand, so the schedule here. If you still remember, I don't want our schedule to be invalid. I don't want to give any chance for invalid schedule. Okay, so that's why now I create this save function. So if you want to create a schedule, so please use this factory methods. Okay, so you will give what is the invoice, what is the due, is test partner, basically exactly the same as the fields. Okay, but now because this is a function, so it will be validated. So the invoice ID will be validated here. Okay, and then it will be, if it is not valid, let's say if the ID is empty, it will return an error. Okay, so it will return a domain error. So if we see our error, well, what kind of error we have. Okay, so it's located here, of course. It's still the same folder as subscheduler because it's still in the same algebra, right? So one folder of algebra contains error, model. Okay, so this error we have maybe schedule not found, and this invalid domain. So for any kind of invalid domains, I will return this error, and it will return like a list of messages. Maybe for example, I am creating a new schedule, and then 2 of the fields are error, so I will put 2 error messages at once. Okay, so that is our model here. So sched error, so save will, if it's successful, we can get the IO of schedule, but if it's an error, we will get the IO of error. So that's we are using ZIO now. Okay, so that's our model. And again, save means this is like our validation function, right? Validation is very common for business logic. So validation must reside on the core, okay? Because it's part of the business logic. Okay, now we have this live here. Unlike the other 2, okay, we don't have implementation of this algebra. I will tell you where the implementation is later. But now in subscheduler we have live here. Live means the implementation of the algebra. So this is implementing this algebra, okay, this algebra, okay. But now to handle all of this operation, of course, subscription, this subscription implementation, this the scheduler algebra implementation, it needs these bunch of classes like invoice algebra, okay. It also needs a subscription algebra. It needs a repository to put the new schedule, okay, and also it needs a config. I will tell you like why this needs a config. Okay, so get is basically just calling the entry repository. Save is by saving to that repository, okay. And then of course, like this repository here, is actually only a trait. So this is a part of the core. Repository is only a trait. So the implementation of the repository will be implemented in the upper layer, in the infra, okay. So now our repository can also return a stream here. So now our repository we can ask our repository, like, please give me the schedule from this day up until this day, and we can get a stream of schedule out of it, okay, which is pretty nice and powerful. Okay, so back here, so let's talk about how to stream due schedule is part of the algebra, right? So what is the implementation out of it? So of course, we are just calling the repo, right? Like, hey, can you give me all of the due schedule? Okay, so first I will try to detect what is now. So this is like the ZIO way to get now, like datetime.now. So due time is basically current time, okay. and then this is from. Okay, so from is like maximum days in the past. Okay, so maximum days in the past is actually configurable from config. So that's why our subscription scheduler live needs a config. But of course, config, where is config is located, where is it is declared. So it's declared actually in the bottom here. So this is our config. Okay, that's our config. So it's okay. So it's part of the core. So it's okay. It's not as we have discussed before. Sometimes config is like declared in the application layer. So we are not accessing application layer here. This is only a core. Okay. So again, so from, we have from, and then this is now, and then we can just ask our entry repo, because we have discussed before that we can just ask stream schedule from and to from the repo, and then we can get a stream from the repository, and then we can just return the stream. So it's pretty much handy, pretty much easy from the algebra perspective, because all the hard work is located inside the repository. And then also this is one of the most important function here, like process outstanding invoices. So if you still remember here, like stream due schedule is like we are getting the stream of the all of the schedule that is due and needs to be processed. So we can just call that. It's actually not calling, we are just using that. Okay, so we are using that, and this is a stream of billing entry, and then every billing entry I will call this get invoice. Okay, and then because I want to get a particular invoice from that billing entry, and then I will revoke from the invoice. I will revoke all of the subscription, okay, from the invoice. So let's see how this implemented. So first, of course, getting an invoice, I need an invoice algebra here. Okay, so invoice algebra, get invoice, I will get an invoice. Okay, and then from one invoice, I will get this function revoke line items. Okay, so this is the function that I call revoke line items. So what is the invoice? So this is the invoice that is returned from the algebra, and then this is the schedule entry. Okay, and then we can basically, if the line items from the invoice, we have like several line items from the invoice, and if the line items is cancelled, so we need to revoke it. So I don't want to really deep dive on the domain now, but it's more about like we can use stream. Okay, and then even though we are using stream, there is no particular like infrastructure specific or technology specific things happening here. Everything here is purely business logic. Okay, even though like maybe stream maybe it's not kind of you will think stream as an infrastructure things, right? But actually no, stream is very part is a part of the core, because I will consider stream as our core libraries, as in like ZIO is our core library, so core is okay to access that library. Okay, so that's actually live. Sorry, live is the name of the file. So basically this is the implementation of the algebra. Okay, so now I will answer you. So what is invoice algebra and subscription algebra? Like, where is the implementation here? Why we only have implementation of this algebra, this subscription scheduler algebra? What about this invoice? Why I don't have implementation? Okay, so I will tell you something. So imagine we are in this environment. So we have many other microservice. Okay, so actually there are other microservice called invoice service. Okay, and then also there is another microservice called subscription service. Okay, so luckily we don't need any more business logic, because the logic is there. It's inside that microservice, so we don't need to implement it. So what we need to do now is calling from the endpoint, from the HTTP. But from the perspective of core, of course there is no HTTP. Okay, sometimes I always find that people will put clients, like even though it's in the core. So if I want to call maybe invoice from HTTP, I will create a trait called invoice client in the core. Okay, so basically it's like a hint that actually this is a HTTP client. So instead of giving a hint that this is a HTTP client, I will just use this as an algebra. So we don't know whether this is a HTTP client or not, right? We don't care. Maybe it's a gRPC client. We don't care about it, right? So from the perspective on this, but if you see any kind of algebra and it doesn't have any kind of implementation, so it means it is a client. Okay, so invoice and subscription will end up actually the implementation of algebra is a very simple HTTP client without any business logic. Okay, the business logic is actually in other microservice. So that's like how I handle client in this particular project. Okay, so now, so let's see like what is the implementation of this client. Okay, of course it will be located in the infra. So infra client HTTP, okay, will contains those two misimplemented algebra. So invoice and subscription. So invoice and subscription. So it's a HTTP client, but because this is a dummy project, I will just make a dummy HTTP client, which is actually not calling anything. But for example, any kind of HTTP client, it needs an endpoint, right? So where the URL it needs to fire on, right? So yes, so invoice HTTP client needs a config, okay? And where is config is located? It's located here. So this is part of the same project. So it's very safe. It's not accessing the application layer, okay? Yeah. So basically the config is a URL, okay? And also, I forget to tell you something about layer here. So we are using ZIO layer here. Okay. Okay, so before I tell you about ZIO layer, so let's see, create invoice is basically creating a dummy invoice. So I will just ZIO succeed build invoice, and then also get invoice here. I will just yield a build invoice, no matter what the invoice ID we might pass from the user. Okay, so that's basically a dummy kind of class. Okay, so now Z layer is like the ZIO way of doing dependency injection. Okay, so if I want to create invoice HTTP client, okay, so I want to create it in a safe way. There is something called resource or Z manage in ZIO, but this is like the powerful way to do that. So we don't need to care anymore about Z manage or Z resource whatsoever. So I can just ask from the ZIO, from the, so basically in Z layer, it internally has some kind of maps. So we can ask that map from Z layer, like, hey Z layer, okay, I want to get invoice algebra, okay, I want to get an invoice algebra. So we can see that layer here. We can see that. So if I want to get, yeah, this is actually not right. It should be invoice algebra here, but okay, it's fine also. So I want to get an invoice HTTP client, okay? So if I want an invoice HTTP client, please provide me with the config, okay? So hopefully the other guy from the wiring layer, the other guy will provide the config. So now I will successfully create an invoice HTTP client. So that's like every class implementation must have its own layer to make it simple to create in a safe way. So invoice HTTP client and also subscription HTTP client, okay, also needs a config, and also this is only dummy, okay, and also we have ZIO layer out from it. And of course, in our core, so if you remember correctly, so we have the implementation of the algebra, and we also have layer here. But of course now our layer is more demanding because our implementation here needs like four classes. So that's how like now our layer is like, if I want to create a subscription scheduler algebra, I want this. I mean, please provide me with this, okay? If someone else provide me with this, okay, so I will successfully create this by calling this, by calling new subscription scheduler live, and then just put them together, okay? So that's how every concrete class has layer. Okay, so now this is the infra client HTTP. So basically it's only dummy, okay? So basically, let's say this is not a dummy, right? So maybe we can actually call the HTTP. So maybe when we are calling HTTP, we will handle with JSON. Maybe after we successfully call our HTTP client, we will get the JSON. So please somehow at the end, please transform from those JSON back to our domain model. So basically this needs to return a domain model invoice, right? This is invoice from the core, okay? Do not return something, maybe something with JSON or something, right? Because our core doesn't know anything about JSON. Just please transform it back to invoice. Okay, now that's our infra. And of course, like our core, if you still remember it, we still have one repository here for schedule entry. So now we are creating it here in our infra, okay? And also, Okay, so now the naming scheme of our project. So the naming scheme of our sub-project here is very important now because we can see that like infra.client.http. Okay, so infra is the layer, and then client is the type of the of this particular layer, like what is the purpose of this. This is a client. Okay, so even client has many technology, so I want to highlight the name of the technology also, so that's why it's like infra.client.http. Okay, do not reorder it, do not rename it as infra.http.client. Why? Because I want like every client will like close to each other. For example, I have gRPC client in the future, so I will put it like infra.client.grpc, and the folder will come up together closely with each other, right? But if the name is infra.http.client, and then the other name will be infra.grpc.client, well, maybe they will be like far apart from each other. So yeah, so I will prefer this naming scheme. Okay. So that's our infra client, and of course now repository. So I will name it as infra.repo.memory. So memory means this is only dummy. In the future, maybe I will use a DynamoDB or Cassandra. So I will just add a new project name infra.repo.memory. Okay. Okay. So this is our infrastructure memory repo, which is only dummy. So I'm using ZIO ref. Okay. And then this is a map. So ZIO ref is basically like a safe way to get a state from ZIO. Yeah, so basically we can get, I don't really want to deep down into it. Basically we can just get a save, just putting that in the map. So this is actually a map of string and schedule, right? And if I cover it with ref, okay, so wrap it up with ref, okay, but basically inside the ref is a normal map. So I will just any like saving this schedule if this is successful. So this entry schedule will end up saved inside the map. Okay, and the key is a invoice ID of the schedule. Okay, so that's the save. That's remove. I will remove that from the map. And this is the interesting part: stream schedule. Okay, so basically we are just returning the maps. Okay, and then after we returning the map, we will just wrap it to ZIO stream, right? So that's very simple to do. Okay, so now like the next challenge is I want to create in the future. I haven't implemented it yet, so in the future I will add a new project called infra.dynamodb. Okay, and it will call a real DynamoDB. So now get is calling DynamoDB, save will call DynamoDB. And what about the stream? So how to stream something from DynamoDB? So it's actually a very interesting part. So I will remind you what streaming is. Okay, so streaming means we will handle, okay, schedule, maybe not everything. Let's say I want all of the schedule from here, from like this, from, and then up until 2. Okay, and then I will get like maybe 1 million of schedule. Of course, it's not 1 million, but this is for example. So I won't get like a blast of 1 million entries at once, but I will get maybe 100 instead, like at one batch. But the batch is small, so it's very processable in one computer. So that's the power of streaming. Okay, so how to do that in DynamoDB? Actually, the idea is quite easy. I have implemented it before. So we will just scan the DynamoDB. Maybe it's query. So we will query the DynamoDB. Okay, and then we will get a batch of 100. Okay, and we will get like the iterator key. And then if we call it again with this same iterator key, we will continue another 100 item from DynamoDB. So that's how the streaming will happen with DynamoDB, and I will wrap it with ZIO stream. So, but I haven't implemented it yet. Maybe in the next video where we will see how it will be done. Okay, so this is only dummy memory. Interesting part, dummy memory. Of course, it doesn't have initial value, so that's why inside the layer I have like a very small parameter here, whether our user want it to be initialized or not. If it is initialized, I will like fill up all of the map with this schedule, right? So our schedule will have like 8 days in the past, and then now, and then maybe 1 day in the future, 5 days in the future, and then we will see like an interesting result if you want to play around with it. Okay, so that's our infra layer. And then now we are coming to app layer. Okay, so remember app and infra, they are actually in the same level, right? So let's open CLI. So this is CLI. Okay, so inside okay, so CLI is basically a console-based command line kind of application. Okay, so we have app and commands. So actually, I don't really want to deep down about like how to make a CLI application. I'm using ZIO CLI, which is quite handy. But now in our app, we have this small thing, small boot, called small folder called boot. Okay, so boot meant to be its own layer because now boot knows everything. Okay, boot needs to wire up everything. Okay, so our main is actually located in boot. So this is the main. This is like the entry point of our application. That is located in the boots. Okay, so boots contains three parts. Config, we will define it later. We will discuss about it. Okay, and then main, like the entry point of our application, and then the layer. Okay, so the layer, we need to like build up the layer so it can our application can like wire up correctly, and then it will be like bootstrap correctly, and it can run. Okay, so now our app is not the entry point, but this is actually like the meat of the logic of this application. So that's why it's called the apps, but not the entry point, because the entry point is in the boot. Okay, so now we have I will just try to run it. Okay, so I will open SBT. SBT is a Scala build system, if you don't know Scala before. Okay, so inside SBT, I want to go to a particular subproject. So the subproject is called app CLI scheduler. Okay, so now I'm inside this project. If I want to run the project, I will call run. But of course, this is a CLI application. So what do I want to do? I want to list all of the due billing entry. Okay, so I will list it. Okay, so now I get this. So I will get this is like 23, now it's 28. So that's how it's due, right? But we also have like 8 days in the past. It is not included, right? So because it's too far back in the past, so it's not included. So that's actually our stream due schedule is quite correct now. Behave correctly. So yeah, so that's a run list. Okay, so how to handle it? So basically I'm calling this list due. Okay, and then basically I only call the scheduler algebra. So command handler, if we want to use a command handler, please provide us with a working subscription algebra. So I will just call that schedule.streamDueSchedule. We already discussed it before, right? StreamDueSchedule is only calling this entry repo stream schedule. We have discussed it before, so we can just call it. Okay, it's actually a stream. So if we see the correct the type is actually a stream of schedule. So if I want to make our stream to become a list, I need to call run collect. So now it becomes a list or a chunk. Okay, and then because this is a chunk of schedule or list of schedule, so I will just print it everything. So yeah, this is our list. Okay, so yeah, so that's actually our apps, and this is our commands. Okay, so this is actually all of this is coming from ZIO CLI, which is very good. Now let's talk about boot now. Okay, so if we are like limiting our discussion in apps only these two classes, okay, actually it doesn't need to know anything about infrastructure. Look at this app class. It's only want to know about subscription algebra, which is in the core. So I don't know anything about infra, right? So that's why application layer is level 2, because it doesn't need to know anything about another infrastructure layer projects. Okay, so that's why it's in the same layer, same level, right? But if we are talking about boot is important because I want to have this, like how I can have this running schedule algebra. Where it come from? Okay, so it's come from, of course, from the main. Okay, and then we can see here, like I call this basically from the main. I'm asking ZIO, hey ZIO, give me command handler. Okay, and then I get the handler. If I get the handler, okay, when I say I get the handler, means I get the handler and also the schedule algebra. Okay, I mean, like, hey, can I get a working handler? And I get it. Okay, and then I can just call handle command. So this is like the command that we are pressing, like list, enter. So it will be calling handler.handle list, right? So that's it. Like, but how can ZIO can get this handler? Okay, because now we pass it from this, like provide and then layer. So layer is located here. So in package. So this is layer. So layer means I'm wiring up all together. So now everything's coming up. So like, hey, please provide me if someone asking me invoice HTTP client. Okay, so please provide with this. Okay, and of course, invoice HTTP client needs a config, right? So that's why I also provide this with config. So I will tell you about config later, but this is the config. So now invoice HTTP client can come up to the system, and then if anyone asking about subscription HTTP client, so please make it. And of course, subscription HTTP client needs a config. Doesn't matter because we provided it. Okay, and then also subscription scheduler live. Okay, this is the algebra. So if anyone asking about subscription scheduler algebra, please give this, okay? And of course, this needs a config, so I give them the config here, okay? So that's how everything comes up together. So now the last piece of it is actually how to implement config. So before I see you, like, before I'm telling you what is this, so let's see, we have resources here called application.conf. So every application has a configuration, okay? Which means please do not put any configuration in the core, okay? Or please do not put any configuration like file configuration in infra, because configuration must located in the apps, actually in the boots, okay? Because they are together. Okay, so if I want to run this application, at least I need to know what is the max days in the past. This is for config for our service in the core, okay? And then what is our invoice HTTP client, even though it's a dummy, but yeah, so we put it here, and also we put it here. Okay, so that's actually the config. Now how to implement this, okay? So if you still remember, config is located, of course, in the boots, okay? Basically, it's the amalgamation for all of the config, like declared in the down layer, in the lower layer. So let's say, so this config, if you still remember it, this is defined in our subscription. So if I go to definition here, look at this. This is config. If you can see the cursor here. So basically, this is core, right? So this is like config located in the core. Okay. So yeah. So our root config now. This is our root config now. Amalgamates all of those config declared in the lower layer. Okay. And then when I call these magical functions here, default config source.default.loads, okay, it will automatically try to fill that configuration with this value from the file system, from the file configuration. Okay, so that's the magic happen here. Okay, so now I have a root. Okay, I have the root, and actually the root is a layer. I make it as a layer. Why? Because now from the root layer, I can like broadcast its children. Like look at this. I want to broadcast from root layer because someone else needs core schedule, the config for scheduler, and I know for sure that someone else needs a config for invoice HTTP client, right? And someone else needs infra subscription HTTP client. So that's how I broadcast. So like from the roots, and then I broadcast it to tree, because I know for sure this tree is needed by someone else, right? So this is how I do it. Well, this is like Z layer for the core. So I'm mapping it. So conf.core.subscheduler. So this is actually for subscription live config. So this is for infra HTTP client config, and this is for subscription HTTP client config. So now, if you see it, look at here. This is one function, okay? From here up until here, they are all one function. What is the return type? So actually, this function is returning this type. So look at this type, this layer. So layer has this type, any, because it doesn't need anything. Okay, it only needs a file, configuration file. Okay, if the file is loaded successfully, it will produce 3 other config which is needed by another layer. So that's how. So if I come back to this wiring up process, okay, so when I say config.layer, it means I broadcasted those 3 config needed by this layer. Okay, and it's also needed by this layer and also needed by this layer. Okay, so that's how all come up together. So our layer is now successful, and now our applications can be run correctly. So that's our ZIO CLI. So please remember now why our boot needs to know everything is first because of config. Now our config will basically invades like lower layer classes, because this is like declared in the lower layer. But of course it's okay because our boot is, he knows everything. So that's how, like, why boot needs to know everything, because of the config. And then also the other one is when they are trying to wiring up the layer. Okay, so all of these layer are declared in the lower layer, so I really want to bring them up together. Okay, so now our application can runs correctly. But of course, like this is for example, this is a dummy client. For example, this is not a dummy, this is already implemented. For example, assume that we have implemented it, but assume that we have created a new project for gRPC. Okay, so now if we want to use that gRPC instead of this HTTP, maybe the name of that project will be infra.client.grpc. Okay, and then we also have a new class called subscription, maybe gRPC client, and now automatically our application will use gRPC to call subscription service. Okay, so yeah, that's pretty much it for this particular app called scheduler CLI. And also I want to give you one more example which is quite interesting. This is related to making invalid state unrepresentable. So let's create a new invoice, okay, by using add. Okay, so add, and then what is the ID? So actually we cannot based on the business logic, invoice cannot be more than 5 characters. But what will happen if I provide like this bunch of characters, right, for invoice ID? Sorry, run add, okay, and then the ID is AAA like this. What happened is actually we have a very nice error, invoice ID too long. So how to handle that? Okay, so now in our apps, okay, in our apps, so we are handling. Okay, so this is like handle command, and then if the command is add, so we will call add schedule. Okay, so the ID is basically when we are using IAAAA, actually the ID will be successfully passed down to this particular function. So now our ID is AAAA here, and then I'm calling this schedule.save. If you still remember it, this is like, if I want to create a schedule, please use this function instead of calling this directly. Okay, so now because I'm calling that, okay, so it might return an error. If you still remember, the name of the error is invalid domain. Okay, so if it is an error, the flow of the application will not continuing here, but instead it will handle with this. Okay, catch all. It will catch our invalid domain. Okay, so invalid domain is declared in the core layer actually, and then our invalid domain now has a bunch of messages, and then we can just print that messages. So it's kind of handy. Okay, now that's pretty much it for our CLI. Okay, now let's go to the last kind of application, which is a HTTP RESTful server. Okay, so again we have boot for that. Okay, so now our resources are quite different now, because now we need host and port. So where is our port for our server? Where is our host IP address for our server? So now we have a different config, but pretty much the other one is the same. Okay, and then of course this is the boot. Okay, our entry point is the main. Okay, so basically we are just calling API. Our app is here, so we are just try to like call, like get the app. Okay, so we are asking ZIO, please get me an app. Okay, so this is the app, and then I will just use its server resource. Okay, and then I call use forever, and the server will be startup. Okay, but how come how to successfully call that? Of course we need to provide the layer. So this is the layer, so we will wire up everything together, and also the config also. Now the config is similar but different, because now we have the app config here. So the app configs, now we have the config to boot up the application, right? So which means this is created in the app layer. Basically this is the same project, but pretend this is like the different layer, right? So this we have a config of host and port. So host and port is actually a different type. So host is like from Comcast. So yes, so now this is our app config, which has a host and port. Okay, and then like how to make our our framework, our file configuration framework to successfully initialize our port type in the config. So we need to use we need to declare this header. Okay, so yeah, that's basically, this is the config. Okay, main, and then this is the package, and yeah, so that's pretty much it. And this is the application layer. So if you want to create an application layer, please provide us with the scheduler algebra, subscription scheduler algebra, and also the config. Okay, and so why it needs a config? Because remember, we are using the server resource from the main entry. Okay, so if you don't remember it, so I will just go there here. Okay, so this is from our boots. So api.server resource. Okay, so this is the server resource. Okay, so our server resource needs a host. Okay, so host is taken from the config. So yeah, so we have server resource, and then we have roots. So this is like app, only have those two, have roots and also server resource. Yeah, so now actually how to handle like a get. Let's say we are get schedule by invoice ID. So this is the root. So root, and then schedule, and then invoice ID, and then basically we will call schedule algebra, and then we will get by invoice ID, and then we will get a schedule entry. This is not env. This will be scat. This is not invoice, right? So this is the scat, and then I will just return the scat, and then I will just return it as a JSON. Okay, so that's quite handy. And then what about if I want to add a new billing entry? So user will send a JSON of billing entry, and so this will be handled by this variable. So this variable, and then let's change that variable. Actually, it's a JSON to schedule, but please remember that this is a schedule, even though the name is same, but this is model.schedule. So model.schedule is actually here, not in the core, but here. So this is model.schedule, not core.schedule, right? So it's pretty much dummy. It doesn't have .save validation logic. So this is dummy, okay? So, but not dummy as in doesn't have any function. The function is actually just take the value from the JSON, right? So we will get this model, the schedule model. Now from schedule model, I'm trying to create the core model. Okay, so that's how I create. If I want to create a schedule, of course, the only way to do it is by using save function. So now I'm using rec.invoiceID, and then rec.view, rec.isTest, and rec.partner. Okay, and if it is not successful, okay, so pretend it is successful, so it will be continue here. Okay, so we will just save it to the schedule algebra, and that's pretty much it. And then we will create a HTTP created. Okay, so what's happened when this returns invalid error as usual? Okay, if this is invalid error, it won't continue here, but it will continue to catch all here. Of course, it's an invalid domain. Okay, and then this is an error. Errors is a bunch of error messages. Okay, and then for each of the error message, I will just log it. Okay, after everything is logged, okay, I will just put it as bad request. Because why this is an error? Because our user is like providing to us invalid JSON. So yeah, so it's a bad request. Okay, so that's why it's quite important to use validation logic in the core. Why? I will tell you something. So it's very common actually for any project to put a validation logic in the app. So usually maybe this model, so they will use validation logic to this model. Okay, even though it's of course it's our project will still run. Okay, so why we need to put the validation logic in the core? So this is our validation logic schedule.save, which is located in the core. So why it is important to put it in the core? Okay, so my reasoning is based on the principle SRP, right? SRP, single responsibility principle, means A is A, B is B. A cannot do B, B cannot do A. Okay, so business logic is business logic, HTTP is HTTP. Okay, so HTTP can do only HTTP. HTTP will never do business logic. So my reasoning is like validation is part of business logic. Okay, so why validation is based of business logic? Because for example, invoice ID. So why invoice ID needs to be in certain way? Because your domain expert telling you so, right? Hey, you know what? It's very important to create invoice ID to be only 5 characters because of this and that, based on the business logic. So your SRE is not telling you to do that, but this is derived from the domain expert. So because it's domain expert, I mean it's domain logic, so it's located in the core. very important. Okay, so what will happen? What is the consequence if we are like we don't put this in the core? For example, what will happen if we put this logic, validation logic, in the apps? Okay, so what will happen is suddenly we will have a penalty. Okay, what kind of penalty? We will have a duplication. So if you if you still remember when we are adding a new schedule here, okay, sorry, here, okay, so here, so imagine if we are not calling schedule.save, but imagine that validation is located in the app layer. Okay, so now we need a duplication of validating logic. So now it's in the API here, and also in the CLI here. Okay, so we have two validation logic for each application. So that's why it's actually it's very important to just stay to the principle, and then our core is business logic, so just put everything business logic there in the core, right? So yeah, so that's actually our project based on the DDD implemented using ZIO, and I think that's pretty much it. So thank you for attending and watching this video up until the end. Thank you and goodbye.